All right, welcome back. We're going to go over the laboratory manual for this particular section. If you notice, we're down at the last one, which means that I'm going to set up a time for a review. I may post a video kind of reviewing things, and I might do it as a live type of presentation, and so I can incorporate any questions that we have along the way while it's being recorded, so you can go back and look at it again later. I think that's probably the best type of thing I can do for this, and I think I'm set up here electronically to do it, so we'll see how that goes. Anyhow, I may ask a poll later, I guess next week, for the poll to get the roll if you want to have the review interactive. So this section is on aerotolerance, and it's just a fancy way that we're growing those that like to grow anaerobically, typically. And the obligate anaerobes, they are a interesting group on their own. They have to grow in the absence of oxygen, and now I don't know why I became in part of my graduate work I had to it was a TA, a teaching assistantship, that put food on the table while I was in school to learn the various things, and nobody would step up to do the anaerobes. Everyone hated the anaerobes, and I guess the biggest reason for that is they're stinky. They stink a lot. The worst smell you could imagine. It's one of those that you become encased in it, basically. So anyhow, the ones that are usually the worst is the Clostridium species. These are your obligate anaerobes. The gram-positive bacilli, and I think I will get to a picture here. I'll show you a picture of some. They have no arrangement. They appear single, and there are about 150 different Clostridium species, but the ones that you're going to run across are listed here. Some of these will be your worst nightmares. I'll start with Clostridium difficile, or C. diff. Usually, how do I explain the type of diarrhea that this organism is capable of to put a patient in this case is explosive. I was an orderly at a Moore Memorial Hospital in Southern Pines for about 6 months, about all I could take. And one of the jobs that I had to do, amongst other hideous jobs, was to clean walls that had been sprayed by patients with C. diff. And some doctors were covered too, but I'm not going to go into that detail. But C. diff smell, I think I ended up throwing away the scrubs I was wearing because I couldn't get the stink out of the scrubs. It's that bad. And the reason I put on that, because I just want you to know how it impressed my brain. C. diff, C. difficile. So it causes a disease called colitis, and which is inflammation of the bowels. It's characterized by watery, frequently defined at least 3 different bowel movements a day, diarrhea, fever, loss of appetite, nausea, abdominal pain, common symptoms. C. diff to uninfected patients through direct contact and contaminated surfaces. So it's of risk to you as well, and I want to point that out. It is nasty. It's they don't talk about the explosive force in here, but it is, and unfortunately it affects those who are undergoing a intensive antimicrobial therapy. And C. diff gets an advantage to grow because it is a gram-positive, and most of the time we're dealing with gram-negatives that are intestinal type of disease. And so if we, let's say, use tetracycline, it doesn't do anything for Clostridium difficile. It says, oh, gee, thank you for allowing us to grow. And they do grow, and they grow in high numbers, and it's like packing gunpowder. It's bad. So there you go. Defacil includes exotoxins, and they are gamma hemolytic on blood agar. Clostridium perfringens, also well known for gas gangrene. You will see this. You will see the Clostridium difficile, you'll see perfringens, unfortunately gas gangrene, with patients that have type 2 diabetes that are just not going to change their lifestyle. And what they'll end up doing is their peripheral, their hands and feet will essentially start rotting. And one of the issues with that, of course, is the immune system's hammered. Anything that gets fueled by ATP and energy, usually the periphery is the first to go. And you'll see it blackened toes and things like that. And of course the doc is going to say we're going to have to amputate, but usually by the time people are willing to do that, gas gangrene is already set in. And tissue necrosis is one way to put it. Again, the odor of perfringens, it's one that you'll never forget. It is pervasive. It is extremely strong. You could have a patient with perfringens and you could literally smell it in the parking lot coming to the hospital. Same with C. diff. It's one of those things. Perfringens also causes food poisoning, and we have moderate diarrhea, but perfringens causing gas gangrene is well known, and it's bad. C. botulinum is another one. Now, if you find a can at a grocery store that they're designed to allow a little bit of expansion, because, well, we don't want cans of soup and things exploding in grocery stores. It's not good for business. But one of the things that can happen is that bacteria will start to grow inside, producing gases if it's unfortunately been contaminated, and the can will become distorted. Do not buy cans that have been distorted this way. Now, some of them can be dropped and get contaminated, but sometimes the cannery will have, every now and then, we do have problems. And anyhow, you can have this happen. But botulinum is one of those that is extremely, extremely dangerous. It can cause botulism, and it causes blocking of muscular contraction, which is not good, because it affects the reuptake of neurotransmitter acetylcholine. In other words, when we now contract the muscle, we of course transmit the effectors, and it's like a baseball pitcher throwing the ball to the catcher. If the catcher doesn't get a ball from the pitcher, that means we're not playing baseball anymore, because we're not throwing the ball for the batter, and that means muscles like the heart will stop and things like that. It's not good. This has been weaponized, and it is extremely toxic. I've seen demos when I was at the vet school where the instructor brought out two gentlemen in positive pressure suits, had a little swab and an extremely small little vial of weaponized botulinum toxin. Didn't touch the nose of the ewe, just came close, and that ewe dropped like a rock, dead. I would not have believed it if I didn't see it myself. And why we'd have such a hideous type of weapon, we do, and our enemies do as well, I'm sure. It supposedly was destroyed and we don't have it, but if you believe that, then I have a bridge I want to sell you. You can just drop me an email and I'll be glad to make the sales pitch for you. But also, those that like to have the puffy lips and things like that, it uses this product that you can buy, that you can inject and make your lips puffy, or whatever it is, that get rid of wrinkles and things like that. And it does paralyze the muscles. Botox, I believe it's, yes, the Botox is the name of such a wonderful product. You wouldn't get me willingly. If you look at the label, to look at the possible side effects, my guess is that you wouldn't buy it and or use it. Clostridium tetani, tetanus. I would imagine, and I would hope most of the students that are taking this course have had their tetanus shot. They usually give it about a 10-year lifespan on that. Working in the veterinary profession, a tetanus shot is very, I keep that up to date, and also various other vaccines for things that you wouldn't like. But the problem is the tetani causes the muscles to contract, and you get into this tetanic spasm, and it can stop breathing and various other things. So tetani is bad. It's a soil microorganism. Typically, it can get its way into a wound, and usually you can step on a rusty nail is the old way to kind of look at it. But that's true. You get soil microbes. It could be Clostridium tetani. Get in, and then you can get tetanus from that, and it would be really bad. And so we want to have vaccines for that. Sporogenes, Clostridium is not as harmful. It can be a symbiont that with those that colonizes the species can use the amino acid tryptophan to produce this indole propionic acid, a plant hormone that can serve as a potent antioxidant to humans. Sea sporogenes can be found in the soil, freshwater, various things. I included a picture of typical Clostridium type species, and if you look, you see these little dark ends. Those are spores. This is spore mite. If you were to zoom in to look at it, it has these very scary looking sort of design like this, and you see those, you know you're dealing with spores. And of course you have these movies where you have they go into old tombs, Egyptian tombs and things, and oh my gosh, the spirit of Hooby Hooby is coming after you. No, it's a spore, probably been sitting there in those dirty bandages that they wrap the mummies in, and they unwrap them, and of course they get aerosolized, and you breathe it in, and then you get a spore, and they germinate. It could be Clostridium botulinum, as far as you know, and the next thing you know, you're dead. And no, it was not a ghost from the past. It was just dirty linen, essentially, and I'm doing that without any breathing apparatus or anything. And hey, you know, you get what you get. So C. diff, Clostridium species, have a plate. It shows you it growing on a blood auger. It usually gets really dark. Now blood will do that when you grow them anaerobically. Sometimes the oxygen tension, of course, is very low. And by that case, you'll see that the plates darken, but they don't grow exuberantly, but they grow. You can see them on there. But these have to be grown. Now we had a case with the lab that I was working in, and I kept all of my cultures in these really nicely kept glove boxes. And these are kind of punched out, but you put your hands and go inside, and these go on the inside, so you can now work anaerobically in these chambers and inside, and you can grow things. And now they have computers and visualization things that you can go in, and it just makes it a lot nicer. But you put things in here from the regular atmosphere, and then you usually discharge a CO2 canister that blows CO2 and devoids, or usually the preferred method is something that incinerates the oxygen and literally gets rid of the oxygen. And then you can open the door on the inside, this part right there, get inside using your gloves in the glove box to open this up, and you'll transfer it. If you don't do it this way, let me tell you what happens. It kills everything. Exposure to oxygen with these types of anaerobes, they get exposed to the air, they're dead. And that's unfortunately happened. I had a really low-end glove box. In other words, it wasn't as nice as this. It was a tent sort of environment, had a very crude way of getting things in and out, because I had to make a huge number of plates for teaching. And so we had these setups so that I could inoculate the plates and just get them ready for class. These are usually used for types of research where you could grow your strains and blah 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 and handle them, and then you put them in containers that you can take out of this facility here, or this little containment area, and store them. Well, the janitor came in, which he was doing what he was supposed to do, and we had a weakened area of plastic. It gets old, plastic. I don't know if you've ever seen, it's just like camping or raincoats and things. They get a little bit more fragile as they get older, and I've been teaching for a while. Anyhow, the handle of the mop hit and pierced the plastic, and the thing deflated. The absolute, I guess, I don't know the best word to say, the goodness of the smells of inside the containment area now baptized the entire building that I was working in at the vet school, the main building that housed the library. And of course this happened on the weekend, and I was not notified until that Monday. And how should I say this? The school became rank in terms of its odor. It is the worst nightmare smell you could imagine times 10. And of course it came out of the lab I was working in, so I got a great reputation. And I certainly got funding to get a new series of anaerobe chambers. That was one of the good sides of it. The bad side from it is I lost all my strains, and it was a lot of work. Unfortunately, I was using my seed stocks at the time, so I had to go back to my frozen cultures, and it's a pain. It was huge. But anyhow, that's what these are about. We don't have those. We use the cheaper ends. We can either use just a small anaerobic jar that has some sort of I don't know if we call them little energizers, or they burn, or it's a chemical reaction. They burn up the oxygen, and then and they put CO2 in the atmosphere, and they displace it, and you have an indicator to let you know how much if the charging has taken place, so it turns. The ones that I'm familiar with were white, and when they became anaerobic, they became blue. Some of them work just the opposite. They're blue, and if they happen to turn white, then you know you have an aerobic condition, which is bad. But you can grow them in there, get your anaerobes, and sometimes they have little pressure gauges on them if you want to show how much. And of course, it's always fun to open these, and the goodness of the odors will treat your nose to a bouquet of odors that you probably, if you were able to cut your nose off with a pair of scissors, you probably would do it. It's that bad. So anyhow, anaerobe cultures. Now we can work with different bacteria that have various requirements that it all centers around oxygen. So now I'm switching a little bit from the standpoint that not only did I work with anaerobes, of course, I worked with other ones that had certain degrees of oxygen sensitivity. In other words, oxygen's a bad thing for some bacteria, and some of them need the oxygen, or some of them don't care. And so I'm going to talk about that kind of group. But we can use a type of media called thioglycolate, and it's a enriched media, but sulfur is highly reactive. Now, everyone has worked, or females anyhow. If you get a hair perm, you get that mercaptic smell, that sulfur smell, and it's that sulfur that does the double bonds from hair to hair. You get a perm. What holds it basically in place is sulfur. Sulfur is pretty reactive, and so that's what you want. You want this substance to sequester molecular oxygen by binding to it, and then keeps the harmful effects of the oxygen from getting to the bacteria. And then we can pour just a little bit of rezurin, which is a oxygen indicator, to let us know in the presence of oxygen. So what we want to do is to see if the containment's working, and if so, that sort of thing. So here's the anaerobic condition will be here, And organisms that absolutely cannot be exposed to oxygen, you will find them as far away from the oxygen source as possible. So you can identify where the growth is in various series of sundries of these. So anaerobes can grow. Facultative anaerobes can really grow in any environment. They don't care if it's bring it on. They can handle it. And so you might see the whole tube kind of consumed with it. They don't really care. Microaerophiles, they can handle a little bit of oxygen, but they can't grow in the absence of it, and so they're kind of really futzy little, and so they'll create a band. Aerobes will grow at the surface as much. Now, one of the things that's assumed, and I just don't want to make that assumption here, if you have a liquid, just open tube open, if you look at my wobbly tube, it's open to the environment, or you just have a cap that's kind of not snapped on it too good, oxygen will move in. Oxygen diffuses, so it's going to be a higher concentration, then it gets down lower and lower as it goes down the tube, so you get this gradation of oxygen, and bacteria will stop growing at where the oxygen levels are too low to support it, or if you're going from the other environment, it will only grow in areas that can handle just right to the limit of the oxygen. So you might see regions down here of growth. It really depends. And the microorganism just tells you, basically identifies itself with this. The same sort of thing is with agar deeps. In other words, you just stab them, and in the stab where it grows does the same thing, so you don't have to worry with a liquid type. Again, although oxygen diffuses a little bit slower and not as let's say here's the agar, and so oxygen will diffuse through, and usually you don't get as much the movement like you do in liquid, and so you'll see where certain microorganisms will grow where they're happy with the amount of oxygen that is in the environment. So essentially they just reveal who they are to you. That's their personality. The aerobes grow up at the top. Facultatives don't care, they don't care, and then the anaerobes will grow until they're comfortable. It's usually a little bit more pronounced at the bottom and less at the top, because the ones here are just they're not really happy, but they're going a little bit. A candle jar is the cheapest. It's a big glass jar with a metal lid on it, and then you put a candle in there, and then the candle burns until it doesn't have any more oxygen. Hey, then you know it's anaerobic, and then you can have plates in there growing and that sort of thing. So here's your standard tubes with a little reservoir at the top there, and you can see the microorganisms grow. Here's your obligate aerobe. In other words, it has to have oxygen. Facultative anaerobe pretty much grows throughout the tube. Obligate anaerobes will grow at the bottom of the tube, and microaerophiles will try to position it where it likes to grow, somewhere at the top or so. If you notice, it's a little bit thicker, and they have substances that float, secrete them. Bacteria are pretty creative. I just thought I'd point that out. But here is an idealistic viewpoint at interpreting what's going on in the tubes, and this is a good one to study by for class, for the lab practical. You can see the obligate aerobes, obligate anaerobes, farthest away it can be. Facultatives will tend to grow throughout the tube. Aerotolerant anaerobes kind of grow throughout the tube, but the facultative anaerobes, they prefer oxygen, but they can handle the kitchen of low oxygen. And then the microaerophiles will park where there's can handle the just the amount of oxygen that they want, no more, no less. So here are the Clostridium species, and you can see some organisms that follow some other type of names that you probably haven't heard of. I just wanted to throw them in there. I'm not going to ask you about them, but it's good to be exposed to the different organisms. I've had to grow a lot of these, and they are ones that have different requirements. So the only real task is I want you to kind of show a stab and a liquid. So this is a liquid tube here. This is a solid state. So this is a solid, this was liquid. And I just want you to kind of draw what you would see for an anaerobe, for a facultative anaerobe, and for an aerobe, and just make a representation on the tube by drawing on it. Just to, and you can of course use any aspect of the drawings and things before. And then exercise 13, it's all marked in red, is you can go ahead and just answer the questions. This is in Word format. You can either just send me the lab manual with everything in it, and just email it to me, and I'll have that. And so you can do this. The drawing part here, I'm not real, if you want me to look at what you have, make sure you're right, you can take a picture of it, include it, but my guess is, because everything is already kind of diagrammed for you, I'm not too worried about it. I think you can get it, but I do want to know your responses, so you could either just send this page out of your Word document to me, or send the whole thing. It doesn't matter. These files are small. And make sure, well, when you email it to me, I have your email address as to whose it is. But if you could answer these questions, and that's the only action item for this particular chapter. You've got plenty of other things to do. I'll give you a study guide, and we'll do a review for the lab practical. Please take the practice exam that I posted, just so you get used to that environment. It allows me to do graphics in the questions and various other things. The reason why I chose the check marker as a class marker as the software that I wanted to use for the exam. I may have you just leave on your camera during the exam or something like that. We'll figure that out. So anyhow, fill those in. You'll be done with that, and that's the pretty much the last lab that we have working on is this one. I'll do next week. I'll dedicate to a review, and then we'll have the lab practical the following week, and I'll give you a certain amount of time to complete it, one try through, and then instead of the 2 tries I did with the example, just so that we'll have that ready to go. So if there's any questions, just email me. I do have the Zoom sessions at 9 and at 1 o'clock, and we'll go from there. You all stay safe, and have a good rest of your week, and I'll be posting the second half of the class material for this week on the chapter 12 for the immune system, and then move on into 13 next week. So we're moving right on there. We're getting down to the end of the stretch here, so I appreciate your time.